Okay, so lesson 6.4 starts out by talking about something called a reference angle. A reference angle, when you're looking at these pictures, the reference angle is it's always an acute angle, and it is the angle from whatever position you're talking about down to the x-axis. So if this is your angle, theta, then this reference angle would be over here, just to the x-axis. Now, in this case, my angle that I was talking about, theta, was an acute angle already. So in that case, that and the reference angle are exactly the same, okay? Over here, this angle, theta, goes all the way around over to here, to this point right here. So my reference angle is just from that line back to the x-axis. So it's just this little acute angle right here. Same thing with this one. If it's in quadrant 4, if this outside part is theta, so from here all the way around, looks like maybe that's a 330-degree angle or something similar, maybe 315, then this angle right here is your reference angle. Sorry about that. Okay, so this page in your book, page 410, is really helpful, seeing those 4 things, because it tells you what happens in each quadrant. So depending on what you're looking at, what problem you're working on, and where that reference line ends up, that's how you're going to be talking about your reference angle in there. Okay, so let's do a few just as examples real quick. So on this one, they want me to find the reference angle, and this is my theta. Theta is 310 degrees. So first, let's think about what that looks like on my unit circle, and you could sketch it out like this, or you could reference your unit circle, and I'll do both. If I'm thinking about a 310-degree angle, I know it's somewhere over here because this is 270, right? And this is 360. So 310 is going to be somewhere in there. So I know it's in quadrant 4. So if I'm looking back at this, quadrant 4 tells me if I take 360 minus my theta, that will give me my reference angle. Or if I'm talking about radians, 2 pi minus theta will give me that reference angle. So if this angle going around this direction is 310, that's my theta, then my theta, they write it like this, theta sub r is this angle right here, which is just the rest of the circle, right? A full circle is 360. So they did this. They said, let's just find 360 minus that 310, and that gives me 50 degrees. That is my reference angle measure. So that one was a pretty easy one. Okay, this one also pretty easy. And again, let me show you on the unit circle how I could have figured that out. So I was talking about 310, right? So 315 is right here. 310 would be around in here. And so I just needed to find from there back up here, because that would be the acute angle back up to the x-axis. Okay, 7 pi over 4. So now we're talking radians. So again, I'm going to draw my circle here, or my x and y axis at least. Okay, so then I'm going to think about where is 7 pi over 4. Now, if you don't have a unit circle in front of you, remember we count by fourths. So this was like 1/4, 2/4 was pi over 2, 3/4, 4/4 was pi, 5/4, 6/4, or 3 pi over 2, 7/4. So that's this angle right here again. So again, I'm going from here all the way around. Same situation as that last one, where my theta is almost all the way around the circle. I just need this leftover piece right here. That's going to be my theta sub r. All right, so I'm going to take 2 pi, and I'm going to minus my theta, which was 7 pi over 4. Another way to think about that is if I'm at 7 pi over 4, how do I get to 2 pi right here? Well, that'd be 8 pi over 4, so I'm only pi over 4 away. So pi over 4 is that difference. You could use a calculator to figure that out, though. It's really just 2 minus 7/4, right? So ignore the pi's if you're using a calculator and just do 2 minus 7/4. Another way to look at it, though, on your unit circle, here's my 7 pi over 4. I just had 1/4 left to go before I ended up back at the beginning. So that angle right there is going to be a 1/4 pi, or pi over 4. Okay, then we have some that are a little more complicated. So this one, 23 pi over 6, it's negative 23 pi over 6. So already the negative is kind of, might throw you a little bit. And then the other situation is that it's just a really big number. 23 over 6 is not something we've had to deal with before. So I'm going to rewrite that as negative 3 and 5/6 pi. To me, it helps if it's in whole numbers, because when we talk about pi, I know that from here to here is pi. And then from there to there gives me another pi, which puts me at 2 pi, and so on, right? So if I'm at negative 3 and 5/6 pi, that means if it's negative, I'm going the opposite direction. So I'm moving this direction now instead of the other way. So I'm going to go that direction. That spot right there puts me at 1 pi. And then this would be 2 pi. And then another one would be 3 pi. So that's negative 3 pi that I've went around right now, and I'm right here. So I need another 5/6 of the way. Well, this right here would be half, which is 3 over 6. 4 over 6, 5 over 6 would be right here. So remember, these little lines in here, those are sixths. So this is 1/6, 2/6, and then we had our fourth in the middle, right? So this right here is where I'm at. So my theta was all of that, like circling around there. My reference angle, or theta sub r, is just this little acute angle right there. Okay, so let's look back at what that meant in our quadrants. So this is in quadrant 1. So in quadrant 1, theta is my reference theta. The problem is my theta that they gave me was not this part right here. They gave me this outside part, right? So I need to go back and think about how far away am I? Well, if I was 5/6 of the way this direction, that means this is just one more to get me to that whole number. So this is 1/6, or pi over 6. So my reference angle in this case is pi over 6. Okay, now the last one I wanted to look at was this one. So negative 235. So I'm back in degrees now instead of radians. And I'm negative, so I'm still going this direction, right? So this takes me to 180. This all the way to there would be 270, right? So let's back up a little bit. I don't want to go all the way to 270. I want to go just up to 235. So I'm going to call it right here about. And what I need to know, remember, if you're going backwards, I need this angle right here. I need the acute angle from my reference point down to my x-axis. So I don't care about this side this time. I want this side. So this is my theta sub r, just this small angle right here. So I need to know from the x-axis up to there, what was it? Well, the easiest way for me to do that is to say, well, I had already taken 180 this direction, so how much more did I have to go? So what I said was, I'm going to just take my 235 and minus away the 180 that I had traveled here, and then that will tell me the rest of the way, which in this case is 55 degrees. So that's my reference angle. What the book tells you to do in this one, where is it? Quadrant 2, right here. Part of what they ask you to do is say, well, let's take 180 minus theta, except that theta is this side. So in this particular problem, that was weird because I didn't have this side, right? So if I were going to use that method, I would have had to take 360 degrees, which is the whole thing, and minus away this 235, which was this part, and that would give me theta. Then take my 180 minus that theta, which was 125, by the way. So I end up with 55 either way. So I don't care which direction you go to figure that out, as long as you end up with this acute angle. So don't forget, reference angles are always acute angles, which means it's got to be less than 90 degrees, okay? All right, example 2, they want me to find the exact value of this. So I did a lot of looking at the unit circle. So 210 is what they were asking me to find in this one. and they want the sine value. Remember, sine is your y value, so here's my reference point. Negative 1/2 would be the y value of that. So the exact value of this is negative 1/2. Now, I've got a lot of people who are like, why can't I just use a calculator for that? You totally can. The difference is if it says the exact value, if you end up with something like this, square root of 2 over 2, you're going to get a decimal on your calculator, and you don't want that. That's not an exact value. So you're going to have to sometimes reference the unit circle to get those exact values, okay? All right, so then the next one, cosine of negative 11 pi over 6. Now let's think this one through. I don't want 11 pi over 6. I want the cosine of negative 11 pi over 6. But remember your negative values rules. So this is the same thing as cosine of 11 pi over 6. Now I can also, let's say you forgot that. If I went negative 11 pi over 6, I would be going from here all the way around this direction, 11 pi over 6, which would put me right here, right? Well, the cosine value in both of those cases, so 11 pi over 6, it's square root of 3 over 2, and over here, it's square root of 3 over 2. There's a reason why those match, because this rule is the same, right? So I still end up with the square root of 3 over 2, regardless of which way I do it. So I can use my reference angles that I just found up here, or I can use that negative rule that this is the same as this, which gives me this. So that was a previous lesson. All right, the next one, tangent of 330 degrees. I went back to my unit circle for this one. So remember, tangent is y over x. So sine over cosine. So 330 degrees is right here, and I've got my sine and my cosine, right? So sine over cosine in this case would be negative 1/2 over square root of 3 over 2. So let me write that out. So this is negative 1/2 over square root of 3 over 2. Okay, well that's kind of messy, so let's simplify that. This is really the same thing as saying negative 1/2 times, flip your bottom number, so 2 over square root of 3. So then my 2's will cancel, so that gives me negative 1 over the square root of 3, right? Well, the problem with this is most of the time they don't like square roots in the denominator, so I'm going to rationalize that. Multiply both the bottom and the top by the square root of 3, which gives me negative square root of 3 on top. 1 times square root of 3 is the square root of 3, over square root of 3 times square root of 3 is 3. So I have negative square root of 3 over 3. Most of the time, that's what they're going to make you do, simplify it like this. Sometimes, occasionally, they will leave their answer like this, which is always surprising to me because they don't really like that. All right, cosecant. The rule that I want you to remember is that, first of all, a cosecant of a negative keeps the negative. So this is the same thing as negative cosecant of 2 pi over 3. But also remember that this is the same thing, I'm going to just write it down here, as negative 1 over sine. Negative cosecant is the same thing as negative 1 over sine of that 2 pi over 3. Okay, so again, I'm going to go back over here to my 2 pi over 3, which is right here. My sine value is the square root of 3 over 2. So this is the same thing as negative 1 over the square root of 3 over 2. So then let's rewrite that as multiplication instead of division. So this is really negative 1 times 2 over square root of 3. Well, that's the same thing as negative 2 over the square root of 3. But again, they probably are not going to like that you have a square root in the denominator. So I would multiply by the square root of 3. That would give me a negative 2 square root of 3 all over 3. So I would write my answer like this. But again, sometimes they will write their answer like that. So just be aware either of those are correct answers. Most of the time they want it rationalized like that. Okay. The next set of problems that they're going to ask you to do is to approximate to 3 decimal places these values. So I could use a calculator for this, but I still have to do some cleanup here. Don't forget that if you have minutes or seconds, you need to transfer those back into degrees before you type it into a calculator. So this is the same thing as the cosine of 88 and 30 out of 60 degrees. Remember, minutes are out of 60. So this is really the same thing as the cosine of 88.5 degrees, or 88.5 degrees. So I'm going to use a calculator. Got to find one first. Here we go. All right, so I'm going to just straight type in the cosine of 88.5 and get an answer. First though, let's go back. Let's make sure that my mode is in degrees. Then you can do that. So I did have it in degrees. So this is approximately, to 3 decimal places, 0.026. This one I do not have to do any fixing. I can just type it straight in. The difference is this one, that's in radians. So I need to go, let me clear this, go back, radians. Okay, so now I need to do sine of 1.48, which is, I'm going to approximate that to 3 decimal places, so about 0.996. So just be careful, make sure that you're in the correct mode. If there's no degree symbol, that's radians, so you have to switch it back to radians. All right, now I got to switch back to degrees again because I'm back in degrees, so I'm going back to my mode, go back to degrees. And this time they're asking me about cotangent. So be careful, cotangent is the same thing as 1 over tangent. And again, I've got 9 degrees, 10 minutes. So that is 9 and 1/6 degree, or 10 over 60, right? 1/6. Okay, so what I can do is type in tangent of, so this is 1 over tangent, but I'm not going to worry about that fraction yet. First, I'm going to do tangent of, and I'm going to do 9 and 1/6. Is that what it was? Yeah, 9 and 1/6. So I'm using fractions to do mine so that I get an exact answer. I'm going to get that answer. Then I'm going to say 1 divided by that answer. So I hit second, and this button down here is answer. So that gives me about, again, this is approximate, 6.197 to the 3 decimal places there. All right, cosecant, same situation where I'm having to say that's really the same thing as 1 over sine. And this is 43 and 40 over 60. 40 over 60 is the same thing as 4 over 6, or 2/3 degrees. So I'm going to do the same thing I did on that last one. I'm going to do sine of, and I'm going to use this fraction, 43 and 2/3. Get that answer, and then I'm going to say 1 divided by that answer, which gives me about 1.448, 3 decimal places. So that's just some calculator work. Hopefully that's easy for you. Okay, the last set of problems that they ask you to do, they want us to approximate the acute angle to the nearest 0.01 degree and the nearest 1 minute. So again, this is going to take a lot of calculator work, and I'm going to point out what this actually means. So this is saying the sine of what angle is about this decimal. So we're kind of going backwards on this one. They're asking me a little more detail here. So I want to know what this angle is. Well, in order to get this missing piece right here, instead of the answer at the end like we were doing, now I'm wanting this piece. What is the angle? So the way to do that on your calculator is to use inverse functions. So I'm going to kind of undo this sign. So this equals the inverse of sine of 0.6612. And we are going to do this in degrees. So all I want is the degree answer. So I'm going to use my calculator, and I'm going to do inverse sine, which is right above it in green for me. So I'm going to do second sine. That gives me the inverse sine of 0.6612. Get an answer. So that's giving me the answer in degrees. So this is about 41.39, and that's where they wanted me to simplify it to. So 2 decimal places is what they wanted me to simplify it to. So about 0.39 degrees. But they also want a second answer. Part B, they want it in minutes. They want me to put minutes in there, not seconds, but minutes. So if you remember back, this is the same thing as saying 41 degrees plus 0.39 times 60 minutes will give me that minute part. So we've done this before, but it's been a while. So that's going to give me 41 degrees, and 0.39 times 60 is 23.4, and I do not care about that 4, that 0.4. All I care about is the minutes. So this is 23 minutes. 0.4 times 60 would give me the seconds, but I don't need that. I just need the minutes. So there's that. The second one, this one's a little more complicated. I've got a cotangent this time. So now they're saying, not only do we want you to find the inverse to get this, but now you're going to have to do the inverse of a cotangent, which is 1 over tangent. So to make this easier, theta is really the inverse of tangent. If it's cotangent here, it's the inverse of tangent if you do 1 over this value, 0.361. So this looks really weird because I have a fraction with a decimal in it. So I'm going to fix that, and then I'm going to find the inverse. So first I'm going to do 1 divided by 0.361. That gives me this as just 1 decimal, but I want that exact value, the inverse tangent of that. So I'm going to say the inverse tangent, so second tangent gives me the inverse tangent of that answer that I just found. So second answer down here gives me that answer. So I get about 70.15 degrees. And then again, I have to do the same thing I did on that last one to get it into minutes. So this is really 70, so this is my theta, sorry. Let's finish that up. This is really my 70 plus degrees plus my 0.15 times 60 minutes. So this is 70 degrees, and 0.15 times 60 is exactly 9, so 9 minutes. That's it.